In Chapter 1, Lesson 2, Part 2, we are going to move on to the quotient of powers rule. Remember, quotient means the answer to a division problem. We'll be applying it again to simplify exponential notation expressions. The quotient of power rule states that when you're finding the quotient of two expressions with the same base, that you can subtract the exponent of the divisor from the exponent of the dividend and use it with a common base. So if you have an example of b to the 6th power divided by b to the 4th power, you're simply going to subtract your exponents this time and to simplify. So you'll keep the base of b and then do the subtraction of 6 minus 4 to get 2. A lot of times in your practice work, you're actually going to see it written as b to the 6th power over b to the 4th power. So it'll look like a fraction, but remember, a fraction is simply a division problem. This will work with any base as long as they are the same in both the dividend and the divisor. Here we have some examples done for us with the division sign here, 3 to the 5th divided by 3 squared. Because the base in both is 3, I'm going to apply that quotient of powers property and do 5 minus 2. 5 minus 2 is, of course, 3. Letter B here, negative 2 to the 8th power divided by negative 2 to the 4th power. Remember that because we have even exponents here, you could have already changed this to 2 to the 8th power divided by 2 to the 4th power if you wanted to. Simplify that to make it positive at the start. Again, that only becomes a positive 2 because those are both even exponents. But if you didn't want to, you can do it as they did it and keep it a negative 2 and use the quotient of power rules to subtract the exponents. 8 minus 4 is 4. And again, because we wind up with that even exponent, they simplify that negative 2 into a positive. Here they give us an example of a decimal, 2.3 to the 9th power divided by 2.3 to the 2nd power. Same thing, 2.3 is the base in both. So we are simply going to do 9 minus 2 and keep our base of 2.3 and our exponent of 7. Now we have the opportunity to do some praxis here with the guided lines given to us. So number 17, 6 to the 19th power divided by 6 to the 14th power. Because I have the same base, I'm going to use that quotient of powers property. So that tells me that I'm going to keep my base of 6 and do 19 minus 14. As you know, 19 minus 14 is 5. So that simplifies to 6 to the 5th power. Number 18, negative 4 to the 7th power divided by negative 4 to the 3rd power. Because it's the same base, I'm going to use the quotient of powers property. And I'm going to do negative 4 to the 7 minus 3 power. 7 minus 3 is 4, so I have negative 4 to the 4th power. Again, our 4 is an even exponent, so that means I can simplify this by making my base positive. So 4 to the 4th power. Number 19, we're practicing with fractions. 1/3 to the 17th power divided by 1/3 to the 11th power. So I'm keeping my base of 1/3. Again, I'm writing that fraction in parentheses simply to show that the whole fraction is being raised to that power, not just the numerator or denominator. So anytime dealing with fractions and exponents, I recommend doing that. So coming back, I'm going to use the quotient of powers property and apply that so that I subtract my exponents. 17 minus 11, of course, is 6. So I simplify all the way down to 1/3 the 6th power. A little more practice here, this time with some variables. Number 24, x to the 9th power divided by x to the 7th power. Because I have the same base, I will use the quotient of powers property. Because I have the same base and because I'm dividing. So x to the 9th divided by x to the 7th becomes x to the 9th minus 7, which simplifies all the way down to x squared, or x to the 2nd power. Here in number 25, negative r to the 12th power divided by negative r to the 2nd power, same base and using division. So again, the quotient of powers property. This will simplify down to negative r to the 12th minus 2, which is negative r to the 10th power. Not sure why they didn't provide us another line here, but we know again, because we have an even exponent, this could be turned into r to the 10th power. On this page, we are going to talk about some more examples where we have multiple variables and some coefficients as well. Excuse me. So in A here, we have u to the 5th power times s to the 6th power divided by u to the 3rd power times s to the 4th power. They suggest that you turn this into a fraction, that division problem into a fraction, with everything first going in the numerator and the divisor, which is the second part, going into the denominator. I think that's just to make it a little more visually easy for you. So after you rewrite it as a fraction, you see they have you break it down into two separate fractions here, where your like terms are separated. So we have the u to the 5th power, covered that up, u to the 5th power divided by u to the 3rd power times s to the 6th power divided by s to the 4th. So now you can use the quotient of powers property and simply do the subtraction with the different variables. So now we'll have 1u, 5 minus 3, and 1s with 6 minus 4. Do the subtraction, and this turns into u to the 2nd power and s to the 2nd power. And we could just have those butted up next to each other because they are variables. In part B, they add some coefficients. 16 in the first term and 8 in the second. Again, write the quotient as a fraction. It's going to help you line up like terms a little bit better. And then you're going to separate everything out with like terms. The 16 and the 18 here are like terms. Anytime you're just dealing with numbers, they're like terms. Then you have a to the 6th divided by a to the 3rd power. B squared divided by b. Remember, no exponent. We add a 1 there because a 1 is implied. Anytime you're just dealing with numerical terms, you're going to simplify by actually evaluating. So 16 divided by 8 is 2. And now for the a's, you will apply the quotient of powers property and subtract the exponents. And same with the b's. Apply the quotient of powers, subtract the exponents. So we are left with 2 times a to the 3rd power times b. So let's do some practice here with the quotient of powers rule with more terms. So the first thing we're going to do here, because we have 3 different terms in the dividend and divisor, we're going to write the quotient as a fraction. So I'm going to place my dividend on top, which is 81 x to the 4th, y to the 17th, divided by 27 x to the 3rd, y to the 12th. And now I'm going to rewrite the fraction as a product of three fractions. Excuse me for my stutter. So first I'm going to do my coefficients, or just my numbers, 81 over 27. Then x to the 4th over x to the 3rd, or divided by x to the 3rd, and y to the 17th divided by y to the 12th. Now that I have them all separated out, I'm going to use the quotient of powers property. So 81 divided by 7, I'm going to do the math there and just simplify it all the way down to 3. And then I'll do x to the 4 minus 3. Again, I keep the base, and I'm simply subtracting the exponents. Keep the y, and do 17 minus 12. So this, after doing all my subtraction, what I would wind up with is 3x, because 4 minus 3 equals 1. So I'm just going to leave that as x with no exponent, and y to the 5th. Let's try another one here. We have w to the 9th, v to the 6th, z to the 4th, divided by w squared, v to the 3rd, times z to the 3rd. I'm going to start out with separating those out into their own fractions by term. I think you guys can see that that's an easy step to start out with. So w to the 9th over w squared times v to the 6th over v to the 3rd. And I'm separating them out with like terms just so it's easier to see what exponents I need to subtract. And lastly, z to the 4th minus z to the 3rd. And I'm going to jump ahead and do the simplification by doing 9 minus 2 with the exponents equals w to the 7th power, v to the 3rd power, because 6 minus 3 is 3, and z by itself, because 4 minus 3 is simply 1. Same thing with number 31. I'm going to go ahead and separate out my terms. First, I'll start with the coefficient here of 169 divided by 13 times d to the 10th divided by d to the 7th. Excuse my lopsidedness. And g to the 8th divided by g squared. So now I'm just going to do my simplification without writing out every step. If it works for you to write out every step, please do so. 169 divided by 13 is 13. D to the 10th divided by d to the 7th will become d to the 3rd power, because when I apply the quotient of power rules, 10 minus 7 is 3. And g to the 8th divided by g squared will be g to the 6th power. And that's it for the quotient of powers rule. Again, if try some extra problems if you seem stuck, and write down any questions you might have for me tomorrow.